the topic seismic base shear. We are making a selective review of some topics for the PE exam. So in this case, we are talking about an ordinary precast shear wall building, and we're gonna be using the equivalent lateral force (ELF) procedure, and we have been given the following values. We have effective seismic weight of 200 kips, and we have the design spectral response acceleration parameter at short periods of 0.3. The structure is at risk category 2, and we are going to be using ASCE 7. Okay, so in ASCE 7, and we're going to start checking. So I already put these values, um, so we make it more easier and understandable. We have on table 1.5/2 the importance factors by risk category of buildings and other structures. These important factors are denoted by the letter I, and we have like different ones. We have for snow is with sub S. We have for ice, which is I. We have another importance factor, which is for wind, that's W, and we have one little e, which is for earthquake. So we're talking right now about 4 different important factors that are listed on this table 152. So in this case, we have been given this value. The risk category is risk category 2. So we have risk category 2 here in this column. These values comes from the table 151. I'm not gonna stop during this particular video analyzing this other table. We're gonna just go straight to what we are required in this case. So we are gonna get the seismic importance factor, i.e. equals to 1, as we can see here. In this case is equal to 1. Okay, so the second thing we're gonna see here is the design spectral response acceleration parameter at short periods is 0.3. So this is the long name for SDS. SDS is equal to 0.3. So that's the SDS is the design spectral response acceleration parameter at short periods of 0.3. So we have SDS 0.3, we have earthquake importance factor equal to 1, and then we have the effective seismic weight of 200 kips, and that effective value is what we call W, the effective seismic weight. And we are going to be probably discussing some more about these definitions in another video, but for the sake of this exercise and this specific topic of seismic based shear, what we need to know is W, or the effective seismic weight, is equal to 200 kips. So we have ordinary precast shear walls. We are given this value, ordinary precast shear walls. So we have tabulated on different tables. Like in this case, I'm gonna just show you the why do we need to know what is the structural system. So we have different structural systems. In this case, we have ordinary precast shear walls. So precast concrete is very common, especially on warehouses. So here on ASCE7, on table 12.2-1, we have the design coefficients and factors for the seismic response modification, seismic modification coefficient response, or R values. We know this as R values. We have all different values here, but I use a copy and paste from ASC7, the seismic force system, the seismic for force resistance system, the first one that we have in this table 12.2.1. The For the sake of this problem, we are only looking for the R value. So in this case, the bearing wall systems. So that's the first part of these different systems that are detailed here in this table. And then we have frame system, but in this case, we have bearing wall systems, and we are talking about ordinary. Number six here is ordinary precast shear walls, and we have an R value equals to 3. So we are dissecting what we find on table 12.2-1. So the following thing we need to figure out is another thing is given in this problem. The problem says use ELF procedure. So what's the meaning of that? ELF, what does it mean? So we're gonna check now this section 12.8, and this section is talking a little bit about the equivalent lateral force ELF procedure. So we have different things that we need to consider. Like for example, on section 12.8.1, it says seismic base shear. The seismic base shear V in a given direction shall be determined in accordance with the following equation. The seismic base shear is going to be equal to CS, which is the seismic response coefficient, determined in accordance with section 12.811, and W, which is the effective seismic wave per section 12.7. So in this case, W is a given. W is equal to 200 kips. We have that. And for CS, we need to check out this section 12.811, which we have conveniently uh, right here. So we have CS, for CS, we have the equation SDS divided by the response modification factor divided by I. In this case, we are talking about the importance factor due to earthquake. It says something, the explanation here. SDS, the design spectral response acceleration parameter, the short period range as determined in section 11.45 or 11.48. R is the response modification factor in table 12.2.1. We already looked for that value is equals to R is equal to 3 in our case. SDS is equal to is a given, is SDS is 0.3, 0.3, and the importance for earthquake is equal to 1. So we can calculate CS. It's going to be SDS, which is 0.3, divided by R, which is equals to 3 divided by 1. So this is going to give us a CS value of 0.1. So the goal for us is to calculate the seismic base shear. That's the whole the whole purpose of this exercise is to calculate the seismic base shear, and the seismic base shear following the equivalent lateral force is equal to V. It's gonna be equal to the CS factor times the seismic weight, which is W. In this case, 0.1 times 200 kips. So V is gonna be equal to 20 kips. 20 kips. That's the answer we are looking for. So usually we're gonna have, and I haven't talked a lot during the last videos about how the exam shows you the answers, but probably you know a little bit about that. I'm not gonna stop waste much time in this, but you usually have like multiple choice. You can have a answer A, answer B, answer D, like different options. One of these options is gonna be probably 10 keeps. I'm just making it up. Probably 20 keeps, 22 keeps, and 40 keeps, something like that. Then you need to choose the option which in this case will be like 20 keeps. I'm just making it up, but that's approximately the way. That's They could be one of the ways they do. Now they are doing different things, like they are doing, okay, just give me a value, some value in keeps, and you need to type, like 20. That's gonna be your answer. Or it can be like um, just different values, like for example, give you like two in one, like what if it's one seismic weight, and what is it if it's a different weight, like let's say 200 and 400, for example. So you need to add two values through at the same time. We will be back in another video with another kind of problems that we can find in the PE exam. So that's all for this video. See you in the next one. If you like it, please consider subscribing and follow for more.